Alessandro Festa, Senior Product Manager responsible for Artificial Intelligence here at SUSE. And today I'm going to present you this session, Future 1111, Artificial Intelligence Innovation Roadmap. We have a small agenda here that will explain you what I will drive you through this session. It will endure around 30 minutes more or less. We will start with the why SUSE AI solution. Then we will move to describe what, in the context of the various actors that typically work within the AI ops, the ML ops, and more generally probably the DevOps. And finally, we will present the when. What did you expect from us to be released and to play with in the context of AI? So without further ado, let's move on this session. Let's start with the why. In today's world, we keep using the word DevOps. It's about operation, everyone that actually operates in the operational team. And with the term DevOps, typically we figure out those people are responsible not just to operate the workloads, to operate the infrastructure, but also to do the automation, to write some code within that to make this workload automated and more usable. Now, with the advent of artificial intelligence, we observe the rising of two new actors within the DevOps scenario, the ML ops and the AI ops. While sometimes those two terms are used as a replacement one of each other, actually they are pretty different. With ML ops, we are speaking about communication between data scientist teams and the operational production team. Those are AI practitioners. The ML ops is a professional that is responsible to be in the end to build the end-to-end pipelines needed to run AI project in production. So it's someone that has a good knowledge around the AI frameworks, about the AI workloads, and everything that sits between that. With terms AI ops instead, we focus on someone that's using artificial intelligence within the existing project infrastructure. More specifically, it's about using AI as a transport technology within the infrastructure. So AI ops is more close to the concept of the IT operational or the DevOps standard job role, while ML ops is a completely new role. It's someone that is more specialized through the AI itself. With SUSE AI solution, we intend to cover both these worlds, both the ML ops and the AI ops, with different projects and with different products. So let's deep dive into that. Let's start with what SUSE AI solution is. So SUSE AI solution is a set of solutions for DevOps communities, including between the others AI ops, ML ops, and IT ops, that remove the complexity of their daily operational tasks. Unlike Red Hat and VMware, SUSE AI solution is a holistic set of solutions, embracing the entire infrastructure, workload stacks, including AI work, application works, and general purpose workloads. So it's literally covered the entire stack of your infrastructure, from the hardware up to the operating system, up to the orchestration management, until the application side of things. So literally the AI project, the AI application you run on top of all the infrastructure. Or in a different way, it's for operational team who need to have a way to build, automate, and monitor any type of workload. And within that definition, we observe three kinds of personas. The data engineers that are responsible for everything around data gathering, transformation, creating and building the data set that data scientists can use and leverage to train their model. The ML op that is responsible to productize the deployment up to the inference of those artworks. He has to gather this data, glue it to the model that the data scientist built, create a pipeline that train the model, and finally serve the model to the inference engine where actually the application can pick it up and use it. And finally, the more generically speaking, the AI ops or DevOps that is responsible for the workload and using and try to use AI within that to predict failures, to optimize the workloads itself, and so on. So to give you a better definition, let's say the data engineer use case is to manage the data workloads and make them always available to other users, more specifically data scientists. The ML ops need to glue complex pipeline, so the data is used by the various teams and by the application at the end. And DevOps is not just AI, but many different workloads. If you want, a DevOps is not necessarily someone that knows AI, it's someone that knows that he's using AI. It's just leveraging AI capability within products actually to make his job easier and better. So let's start from MLOps. What? The inferential landscape is pretty complex. It's growing over and over. And if you try to identify those personas, including also the data scientists here, you will see as for each persona, there's plenty of solution out there, both from closed software and open source software. But when it comes to an end-to-end scenario, when it comes to MLOps, DevOps, where actually you need a platform, a solution that allows you to use and reuse multiple tools, now the market start to have a few solutions. The most famous probably there is Qflow. Seldon is another great solution that helps MLOps to identify when it's time, for example, to retrain a model. But there's not many of them. This is where actually the heritage of an infrastructure company as SUSE can help out. And this is where actually we want to figure out help. And why is that? Well, because of the problem statement. The misconception is that once the model is trained, the job is over. But actually, the work actually is just at the beginning. A model over time will lose its accuracy, its performance, its identity, and need to be retrained. And over time, data scientist team will figure out a new model that will supersede the existing one. So you will have to rerun, reconfigure the pipeline. So the end-to-end life cycle is more complex than what it appears. And if we deep dive into the ML life cycle, this is how it appears actually. It's a set of steps, each one that are used and where the various persona are responsible for. The data gathering transformation, where the data comes. Is it coming in form of a batch or streaming? How do I analyze the data? How do I find out the features within the data that are useful for me? How do I build data sets that actually can be useful later for the data scientist to build a model? Are those features static or they are changing over time? How do we select the parameters within the model actually that leverage those data? And so on and so on. Up to the experimenting, training, tuning, and testing. This is where actually you build the model. What kind of model we are building? Are we using an existing model? We're building from scratch. How do we fit the model? How the model actually perform? How many times we need to retrain the model and how we log the metrics of this model to understand actually its perform as expected. And finally, once we train the model, how do we serve this model to the inference engine so that the application can actually do a call against the model and make a prediction? And of course, we need to oversee the entire process. We need to oversee even the process once it's finished, just to understanding how it acts. As we said before, you train a model, you serve a model, but over time the model will lose its capabilities, lose in terms of accuracy, in terms of precision or performance. When is the right time to retrain the model? When is the right time to evaluate, to build a new model? And is your workload running as expected? Are you leveraging entirely your infrastructure? Or you basically outperform the infrastructure? And so, is there any failure that is coming in? Is there any error that you can predict over time or before time to avoid any disruption in your infrastructure? So the ML life cycle is pretty complex and become even more complex when you observe how this machine learning infrastructure life cycle need to be operated by the operational teams. As we said before, there's no one single solution really. There's no one single platform that allow you to run end-to-end those life cycles, not just few. And few of them not necessarily are the best in breed when it comes to specific steps. So if we split those machine learning life cycle in 4 pillars: data gathering, experimenting, training, productization, deployment, monitoring, auditing, we will observe that within those pillars, there are plenty of solutions, each one of them the best in their specific step. But they need to be glued together. They need to be used together because the various teams, the various professionals will prefer to use one versus the other just because it allows them to make their job in an easier way. And so we start to have two problems. One, as we said before, there's no one single solution that covers the end-to-end scenario. Two, different data scientists, different professionals, different personas, different tools. And those tools are not necessarily integratable within one to each other. They don't have a magic recipe that allows you to glue them together. Some are feature complete, some other are partially feature complete. And so you need to cope with that. You need to find out how the way. There's a lot of manual effort in this operation. There's a lot of possible errors and struggling around building all these steps one to another. So here's introducing the first SUSE AI solution project, FuseML. FuseML is built with the idea that we want to simplify the life of machine learning operators. We want to reuse existing products. We want to glue them together in a way that you don't have to think how it has been done, in the form of a recipe. We offer you a recipe that glues those tools together and is responsible to get rid of the complexity from your hands so that you can focus only on the optimization of the machine learning lifecycle, on the things that really matter to you. So what we offer within the architecture of FuseML? Well, first of all, a Git repo. Of course, you can use Git repo, external Git repos, GitHub, GitLab, and so on. But in case you don't have nothing, you want to use on-prem internally a Git, then we offer Git as an open source solution to start from that. Then we do support various AI store. What is an AI store? Well, whether it is to store the data sets or to store the model or even the containers that will run later the pipeline, we offer various integration with various kind of stores, S3, Docker Registry, and so on. Each one already set up to expose what is matter to you. And finally, two kind of engines, the pipeline engine and inference engine. Think about the engine as a way to take an existing product, MLflow, Tecton, Argo Workflow, Seldon Core, Qflow pipelines, and so on, combine them together in a way that actually can work automatically one to each other. You train a model, you serve the model automatically. You don't have to think about how to do that. All you are needed to do is just define your own recipe, customize your own recipe to use the specific tools that you know already, that your teams know already and typically use it. The result? Well, the result is that a Fluor type is you're using existing technology. You don't have to learn anything new because you already know what you're using. The second is that it doesn't change the way the user works, and it reduces the TCO because if you keep using your tools, but those tools are automatically integratable, and you don't have to figure out how to do so, you're basically reducing the time to go to production. And even further, you can basically go there and create more multi-cluster capabilities. Literally, you can use FuseML to move a pipeline from one environment to another. Because that's another problem that most of AI platforms have to still figure out. Whether it is Qflow or Argo or Converge or other capabilities, each one of those platforms is a single platform on a single cluster. If you want to use 2 instances of a cluster, 3 instances, multi-instance of a cluster, you will have to install and configure and manage multi-instance of those solutions. There's no one single dashboard to manage them all. There's no one single way to integrate them all. FuseML solves also this problem. His goal actually is to act as a bridge, as a broker, if you want, as an AI orchestrator, to provide you an easy way to go there. And it goes even further. There's another session that you can follow between SUSE and Intel where we present how we use the FuseML recipe to optimize an existing workload leveraging the the Intel capability when it comes to AI. But I think visually is better. Visual things are better than just description. So let's go for a couple of short demos. Let's start with the first demo. How do I install FuseML? FuseML is pretty simple. In this case, I'm going to use another SUSE project, Rancher Desktop, that just done been launched. So Rancher Desktop allows me to have a full Kubernetes cluster at my disposal locally. And I'm using a sandbox that we are going to release, the FuseML sandbox, where basically I'm using this in the context of Rancher Desktop just to locally deploy any solution and do my experimentation in an easier way. So the first thing is, of course, install FuseML. And all I have to do is just FuseML install. It will take care of install all the things that I need to start working with the AI specifics. If I don't pass any recipe specifically, it will install the basic tools like MLflow to log the metrics, like Tecton to run the pipelines, and service engines like Seldon, Native, the MLflow itself. So it will take care of everything for me. As you can see, it's installing also Minio as a storage to expose the results of my pipeline. And it goes there without actually having me to do anything there. I don't have to do anything else if not sit there. Even the DNS name of my infrastructure is being given by me. If I don't choose anything, it will take care of create a specific domain name for me so I can reach out everything. So you see, I just installed the first part of FuseML, the core part of FuseML. Now it's taking care of MLflow for me. Now the GitHub repository Git, and then after Git, the Tecton pipelines capabilities. Once it's that, I will just need to point out that URL that you can see here and put in front of that the service I want to use. Like, let's say that I want to use Git, and then I will say Git dot my domain name, and then everything is ready for me. You see also how we installed a registry. As we said before, that was one of the AI store, the basic AI store. You can use that to use the registry as a way to store your custom containers to run your custom pipeline. We're almost there. Tecton is going to be installed, organization targeted. Here it is. I'm opening up my website, and that's it. FuseML is ready to be used. Let's go for a little bit more complex scenario. And let's use FuseML in a different context. So here we are. We are logging in on the FuseML sandbox. As you see, I'm logging in with a specific user, Michael. Who is Michael? Well, actually, we created the sandbox with in mind the idea of provide you a zoo of ready demo templates that you can use. And as you can see, we have 4 personas there. Let's go for those personas. First of all, Sasha. Sasha is a data engineer. He is responsible for the data engineers, so gathering the data, prepare the data sets. Then we got Michael. Michael is our machine learning operator. He's the guy responsible to push this pipeline over time. We also have Jean. Jean is our data scientist, and she's responsible for building the models. And finally, we got Alex. In our case, full stack developer. He is responsible to create smart apps that leverage the lifecycle, the machine learning models that we produced before time. So we will start with the wine example. What is a wine example? It's pretty simple. Wine example is we think we are a company, winery.co. Winery.co is responsible to produce wine. In order to produce wine, you need to predict the quality of wine that's going to be produced. So his idea is to create an application that allows a user, a professional, to input the data analysis of a specific wine and understanding the quality of this wine before actually sending this wine in production. So we can filter what we can produce and what not. So in our demo, we start with this app. Alex developed this app actually to run it. But of course, we don't have yet a model. We don't have any machine learning. So if we run this model and we run this app, and we try to predict anything, the app is working per se, but 4.4, there's no model there. There's no prediction. We can do anything there. Now, without FuseML, that means that such a data engineer need to figure out the data, need to figure out how to build the data, expose the data somewhere, and then talk to Jean. Jean need to use this data, start to train the model, start to write the model, and she has to figure out a way to train this model, to understand the metrics of this model, rerun this model up until she's not happy. And once she's happy, then basically Michael, the MLOps, need to figure out where to serve the model, how to serve the model, eventually write some code to expose this model to the application. But we are in FuseML. So the app is there, it's still running, and all we have to do is basically just push the code that Jean wrote and that Sasha exposed to FuseML. It's like to say, here's the data, here's the model, let's do a first run of the training. And FuseML take care of everything else. And what FuseML does is simply like grab the data. The data can be locally, it could be remotely from a Git repo. Combine this data in a template that take care of everything. Transform that in an application. And once you transform the application, basically you will see that it creates some extra information there and push this as a pipeline within Tecton. Tecton will clone the data, will build on the fly the relevant container that we need to use. For example, in our case, where I'm going to use MLflow to track the metrics, index everything. Do you need TensorFlow? Do you need any specific frameworks within that? We will use Conda as an underlying environment to do everything there. Then we will customize this as a set of containers we push to our own registry. And once the registry is there, we literally can go there and observe the results. Here's the data scientist, see the results of the training. So he can rerun the same step over and over again until she doesn't have, in her case, Jean, she doesn't have the results that she expects. That means that she can literally simply go back to the Git repo, change the code, and automatically the pipeline will be rerun. And it will keep doing that over and over time. In the meantime, FuseML will keep taking care of all the other steps. We are here, we observe the various results, we can see the results, how actually it is expecting, and so on. This is a single run, so there's no really relevant information there. But FuseML, in the meantime, took that model, served the model to the inference engine, exposed the model to the application, and without changing anything, the application all of a sudden is smart. We can literally predict the quality of wine with a single click. And from now on, this pipeline is in production, is ready to run in production. Literally, we can change the code on the fly, and the code will be automatically transformed and pushed to the production line without having to do anything there. That's the beauty of FuseML. As you can see, I literally spent 3 minutes to explain, 3 clicks within the application, and I completely moved from taking the data to serve an application to the production line. So a few things to keep in mind. First, FuseML, as everything that we do at SUSE, is an open source project. It starts as an open source project. So we welcome anyone to contribute, even if contribution is just about opening an issue to request for a feature. If you don't feel good enough to write code, don't worry, there's a lot of room there to help out with the organization of a community, with the documentation, even just to create some issues about things that you'd like to see in the product. We have a micro website available for you to start with, fuseml.github.io. Please reach out and start using FuseML today. And finally, documentation is an ongoing effort. So we welcome anyone that wants to contribute to documentation with examples, for example. Or we can be better explanation of specific steps. Just come here and help out. But now let's move to the other kind of professional. We explained what a machine learning operator is. But what about AI operators? AI operators are professionals that not necessarily knows AI. They're using AI within their existing tools to make their job easier. And within that, we can give a better definition. Human operators cannot manually inspect high volumes of logs, especially with how many new technologies are being adopted. It means I can lose track of what is going on. He's introducing OPNI. OPNI is a new project launched by the SUSECON solutions. And is a set of collection of AI ops tools that literally start with log monitoring Kubernetes. It's a model that's self-training and learn over time to predict failures. And it's already out there. You just go there and start using it. And again, as before, it's an open source project. Means you can help out with issues, with documentation, with coding, with ideas. This is what is about the collaboration in open source project. But OPNI is just the first glimpse of the AIOps solution that SUSECON is going to launch. And they are both, the FuseML and OPNI, part of a bigger project that is what we call the AI solution stack. You probably noticed, if you know SUSE, if you saw other sessions within SUSECON, that we have this stack of solution that goes from the operating system up to the Kubernetes, down to the capability to offer policies and management tools and so on. In the concept of AI, we can see this cube cake, as we call it, as a set of AI capabilities. The AI orchestration platform on top of everything. Sit beside Kubernetes, the platform operational for AI, the IOPS platforms, the accelerated infrastructure, in other words, the capability to run hardware acceleration like GPUs, DPUs, TPUs within the infrastructure. But there's plenty of other things, like the capability to govern those infrastructure from AI standpoint. So in the context of what we presented today, here's how it appears. FuseML is part of the orchestration platforms. We have other projects coming in. Rancher Desktop is one way to locally run FuseML, as you see as you saw in my demo. OPNI is the first glimpse of a AIOps platform that can operate the infrastructure using AI. But even other super important projects like KubeWarden that basically create dynamic policy to access resources within infrastructure, and that goes in the direction of SUSE governance AI, or management tools like SUSE Manager and Rancher Fleet. All those projects combined together offer you a unique solution stack that is focused on AI, whether it is for AI practitioner like MLOps, or whether it is using AI within your infrastructure, like in the case of AIOps. And with that, I thank you for attending my session, and I hope you will have a lot of questions and reach out our project to help out with your valuable knowledge. Thank you.